Hey, so hello everyone. Let's take a look at this particular challenge about implementing queues. And let's first define the question. The question is to implement queues in a way that we would be able to make all of these kind of, uh, I would say, functions to be called, such as is the queue empty? Can we enqueue something? Can we check the size of it? Can we print the queue? Can we dequeue? Can we peek? And yeah, print is just again. So uh, first thing is like you would explain like what a queue is, and think of it like an ATM. In an ATM you would have like people who are just coming. Let's say that this is the ATM, so we have someone like person 1, person 2, person 3, and maybe a new one comes, so the person 4 would not start here, like he wouldn't be breaking the line in the ideal scenario, he would be here. Yeah, so this is how queue work. And if someone has to leave, then a dequeue operation would be like the person from the front would leave, right? This is how it happens in the ATM. So just give a real example and explain, yeah, this is the queue, and now I will have to implement it in a way that I would be able to perform some of the functions like is my queue empty, which is like checking the length of my queue, what's the size of my queue, and can I just print my queue, or can I just have a dequeue operation. Yeah, so dequeue, and can I enqueue, which means adding, and dequeue means to remove, and enqueue means to add. And dequeue operation happens when we are removing from the front, and an enqueue happens when we are adding from the back. A peek, which is like checking uh, the last that exists, which is like we are peeking into the queue. So just to have a peek in the queue would be actually to check the first or the zeroth of the queue, so would be a peek. So we would be just checking that if the element exists, then is the zeroth element there or not, and printing the queue, which is like a two string operation to check and print the queue if it exists. So now we have all of this clear, and this is like what our thinking would look like. So we know what a queue is and how it works. So without any further ado, we can just start implementing it. And I think this is one of the straight away challenges where you can just start implementing just after explaining a bit about queue, because I would say that most of the questions wouldn't be this easy, but this is a setup, or this is a basis for some of the later things that I would be able to explain better if I would do this one right now, which is like prefix trees or tries. And to understand how to implement those, I think that a crucial understanding of implementing some basic data structure is important. So yeah, with this I will be just making a queue. I'll be using my ES6 classes and a constructor, and in the constructor I will just define this dot items is equal to empty array, and this dot size is equal to what's the size of an empty array, 0. So this is what I have defined in my constructor. Surely we can just intend it, and yeah, after adding some intent we can just have this as small case, which is okay. So the very first thing that I'm thinking about is how can we check the size of the queue. And this is the first function where we will just return this dot size, and it's as simple as this. We just return the this dot size, and we would be just changing this when we enqueue or dequeue, so we have the right values in it. And yeah, once we have done this, now we will also be checking is empty, to check that whether our queue is empty or not. And I think this is also very straightforward. Return this dot size is equal to 0. So we are just checking if the size of the particular array is equal to 0 or not. So we have this done, we have this done. Print, we would be just doing it later, so I think I have written print 2 times. Yeah. Next thing is, and I will just do one thing, that I can just write it in a new page, so I have everything covered. I have already finished with size and is empty, so we can just take everything from here to the next page. Yeah. So the next challenge for us is to think how we can use the peak. So peak is like, firstly I will just check if this dot is empty, which is like if I call another function inside it, I will be using this operator because this of it is queues is empty. And if this dot is empty is true, then because I cannot peek, then the return would be like null. But if is like not empty, then we would just have to return this dot items 0. Like peeking would be at the start of the queue, like who is the person who is at the ATM right now. That's it. So return this size. So we have peek as well. Now we are thinking about how can we use an enqueue operation, and I think here comes the better ones that we have to, I mean these are not too hard, but yeah. So this is just like this dot items, and I told you that everything is added at the end, so it is like push operation item. So this is how you can add an item to a queue, and we do not have to return this because this is like an enqueue operation. It doesn't return anything. Now a dequeue would be, a dequeue doesn't receive any item, it is to remove an item. So but this returns something, this dot item, and we are removing from the start, so shift. And this is like how a dequeue works. So we have done enqueue and dequeue. We have also done peek, and we can just put it here. And now what we are left with is just to do the print one. So let's see, print is, and maybe this is something that why I wanted to do this in Google Docs, because you may be seeing that it doesn't have the right tabs or spaces, and it just infuriates me that it doesn't have the right color. But you have to make a habit of that. Like this is how a Google interview would look like for you, and if you make a habit, I think it would just make it much faster for you to type in and use these kind of format. So I can just return this dot items dot toString, and we are done here. So this is all of it, and we would also have to dry run this. Like how can I dry run my particular question here, and how can I make sure that the interviewer understands that I can solve this dry run, and I can make him understand that I know the problem and I know my solution. So the very first thing is it asks to create a new queue that would be created. It is like an items, which an empty array with a size which would be 0 would be created. And I think one thing that is important that we left here would be, because we are pushing an item, this would be size plus plus, and because we are dequeuing, this would be this dot size minus minus. And I think that is something that we should not miss. And because we knew that we are using this dot size, so we have to use it as well. But now we are all good. And because we are dry run, because we're making a dry run, it would get much and much more clear. So we have a queue with items and size to 0. We check if queue is empty, which would actually check if this the size is equal to 0, which is, so it will just return true here. So we can just write this returns true here. And then we enqueue 10, it doesn't return anything. Enqueue 20, enqueue 30, doesn't return anything, but the size every time increases to 1, 2 and 3. So this would return me 3. When I make a print operation, that would give me 10, 20, 30 in the same order, that because they are pushing, because they are making a push in enqueue. When I dequeue it, it would make a shift operation and decrease my size and also my element. So it would just give me 20 and actually it will not give me 20 and 30. And I think this is where you need to see, because we dequeue when we dequeue, we return the element that was dequeued. This is how a shift works. So it will actually give me 10 and the array will contain 20 and 30. and if we peek, so we would be getting 20 here, which is the items of 0. Yeah, and finally when we print, we would be getting 20 and 30, and you are done. Once you have explained this and your dry run, it looks correct with the questions that he had, and the recruiter would be really happy that the interviewer would be really happy that you are able to solve it. But yeah, this is the basis for another problem that I wanted to solve, which is like the prefix tree or try. And with this, I think a very good basis has been set up, and we can complete multiple implementations, like how are graphs made, or how are stacks or linked lists made, or how are doubly ended queues are made, or how are circular linked lists made. So these are some of the other things in DSA which would not be directly asked most of the time. It would actually have some kind of questions where this is like a part of it, where you will have to use it. Maybe like something like BFS approach, where you have queues as a part of it, breadth first search. But more or less understanding how it works and maybe a quick implementation does not hurt you. It actually makes you understand how these things are working and how you can implement your own. So yeah, thank you so much. See you on the next one.